The birth of the antibiotic age. London, September 1928. Inside a modest laboratory at St. Mary's Hospital, a Scottish bacteriologist named Alexander Fleming returns from vacation to find something unusual. On one of his culture plates, where Staphylococcus bacteria should have grown uninterrupted, there is a clear halo, a space where bacteria have vanished. The cause is contamination by a mold. Fleming observes that the mold releases a substance capable of killing bacteria. He names it penicillin. In 1929, he publishes his findings in the British Journal of Experimental Pathology. Yet the world barely notices the problem. Fleming cannot purify penicillin. There is a problem. Fleming cannot purify penicillin. He cannot stabilize it, and he cannot produce it in meaningful quantities. For nearly a decade, penicillin remains little more than a scientific curiosity. The story resumes in 1939 at the University of Oxford. A team of scientists takes up Fleming's abandoned discovery, Howard Florey. Ernst Boris Chain Norman Heat. Chain refines extraction techniques. Heatley engineers methods to grow and concentrate the mold. Florey leads the clinical vision. In 1940, they demonstrate penicillin's life-saving power in infected mice. In 1941, the first human trials begin. The results are extraordinary, but production remains scarce. Then World War II changes everything. Through collaboration between British and American scientists and pharmaceutical manufacturers, penicillin production scales to industrial levels. By 1944, it is being mass-produced for Allied troops. For the first time in history, bacterial infections that once killed millions become treatable. In 1945, Alexander Fleming, Howard Florey, and Ernst Boris Chain are awarded the Nobel Prize in Physiology or Medicine. The antibiotic era has begun. The first commercial breakthrough, Penicillin, 1930s. But penicillin was not the first antibacterial drug used in patients. In 1932, at the German pharmaceutical company, Bayer, physician-scientist Gerhard Domack discovers a red dye compound called Penicillin. Penicillin proves effective against streptococcal infections. Later research reveals that its active component is sulfanilamide. Unlike penicillin, Penicillin is synthetic. It does not come from a microorganism, yet it marks a turning point. The first broadly used systemic antibacterial drug. In 1939, Domack receives the Nobel Prize in Physiology or Medicine. Chemotherapy against bacteria is now a scientific reality. Following penicillin's success, scientists search systematically for new antibacterial compounds. The answer lies beneath their feet. In 1943, at Rutgers University, microbiologist Selman Waxman leads a research program screening soil microbes. His graduate student, Albert Stetz, isolates a compound from Streptomyces griseae. They name it streptomycin. It becomes the first effective treatment for tuberculosis. In 1952, Waxman receives the Nobel Prize in Physiology or Medicine. Historical records later highlight controversy regarding Schatzky's recognition. The soil continues to yield medical treasures. Chloramphenicol in 1947, associated with work by David Gutt. Tetracycline between 1948 and 1953 from Streptomyces species erythromycin in 1952, discovered by Abelardo Aguilar, and later developed by Eli Lilly and Company. A pharmaceutical gold rush is underway. Between 1940 and 1960, dozens of antibiotic classes are discovered. Most originate from soil-dwelling bacteria, particularly Streptomyces species. Pharmaceutical companies establish vast screening programs, testing thousands of microbial samples. The impact is transformative. Major surgery becomes safer. Cancer chemotherapy becomes possible. Organ transplantation emerges. Diseases once considered death sentences, pneumonia, sepsis, tuberculosis, become treatable. Modern medicine is rebuilt around antibiotics. The founders of the antibiotic era. This revolution stands on the work of a few pivotal figures. Alexander Fleming. Discovery of penicillin. Howard Florey. Clinical development. Ernst Boris Chain biochemical purification. Selman Waxman soil antibiotic discovery, and the term antibiotic, Gerhard Domack, sulfonamide chemotherapy. Together, they established the scientific and industrial foundations of antimicrobial therapy, the foundations before antibiotics. Yet even this revolution rested on earlier breakthroughs. In the 1860s, Louis Pasteur helped establish germ theory, the understanding that microorganisms cause disease. Soon after, Robert Koch identified specific bacterial pathogens and developed methods to culture them. Without germ theory, there would have been no search for antibacterial agents. Without microbiology, no penicillin. From an accidental mold contamination in 1928 to an era that transformed surgery, oncology, and infectious disease treatment, antibiotics reshaped the trajectory of human survival. But even as the Golden Age dawned, a new challenge quietly emerged: bacterial resistance. And the story of antibiotics would continue.